Very good afternoon to everyone. Hope doing well, all. So, thank you for your support. But I require your more support by subscribing my channel, by giving like, by making a comment, by sharing my channel to your friends or relatives. So I request you all, please share the channel, like the videos, like the videos with your friends or the relatives. Okay. Like the videos, please share the channel with your friends or the relatives who are going to study either class 8th 9th and 10th, right? So the most important thing I already requested to you, please subscribe, like the videos, right? Watch my old videos which are related to class 10 also. There will be little change happened here. So requesting to you all, please subscribe and share the channel with your friends or relatives. A kind request to you all. This is a kind request to you all. Please subscribe, uh, like the videos and watch the videos regularly. Please watch the video completely. Okay, then only you are able to understand what I am explaining. Otherwise, if you are watching 2 minutes and skipping, if you skip the content, very difficulty to understand. Okay, let us start. Our topic today is writing chemical equation. Writing chemical equation. Writing a chemical equation for a chemical reaction. Writing a chemical equation for a chemical reaction. As we discussed yesterday, in the previous classes, we discussed what is a chemical reaction, what is a physical change, chemical change, and the characteristics of are the features of chemical reaction. So the characteristic of chemical reaction is a gas is evolved, formation of precipitate, change in the color, change in the state, and change in temperature. So change in temperature, we discussed exothermic reactions and endothermic reactions. So in any chemical reaction, if energy or heat is absorbed, energy or heat is absorbed, such reactions are called endothermic reactions. In any chemical reaction, if heat is liberated or produced, such kind of reactions are called exothermic reactions. Okay, now let us understand writing chemical equation. Equation. How we can write a chemical, how we can represent a chemical reaction. To identify the chemical reaction takes place or not, so we know different features, evolution of gas, formation of precipitate, then change in temperature, change in state, change in color. Then how we can write an equation for a chemical reaction? So the method of representing, the method of representing, the method of representing a chemical reaction, a method of representing a chemical reaction by using, by using what we have to use to represent a chemical reaction? By using or with the help of, by using or with the help of symbols, symbols or formulas, symbols or formula of a substance, of a substance, of the substance of of the substances which are involves, which are involves in that chemical reaction. Substances involved, substances which are sorry substances, substances involved in it, involved in it is known as chemical, is known as chemical equation, is known as chemical equation. So writing a chemical reaction, writing a chemical reaction by using or with the help of, by using or with the help, with the help of symbols or formula, symbols or formulas of the substances involved in it. In it means in chemical reaction or in chemical change. In chemical reaction or chemical change is known as chemical equation. Simply we can write the mathematical representation, the mathematical, the mathematical representation, the mathematical representation of chemical reaction, chemical reaction with the help of, with the help of symbols or of formulas. Symbols are formulae, symbols are formulae of the substances, of the substances involved, involved in it, involved in it is also known as the chemical equation, known as chemical equation. For example, yesterday we discussed some chemical reactions. We discussed some chemical reactions. For example, carbon. Carbon reacts with oxygen. Carbon reacts with oxygen and form carbon dioxide. This is a chemical reaction, reaction of carbon with oxygen. This is a chemical reaction. This chemical reaction should be right by using symbols and formulas. Why we have to write a chemical reaction in the form of equation? Because every time we cannot write the chemical reaction in the sentence. So carbon reacts with oxygen, form carbon dioxide. Carbon reacts with oxygen, form carbon dioxide. Every time we cannot write the chemical reaction in the form of sentences, it is very difficult to write. And even we cannot write the name of the substance or the element or the molecule or the compound which involves in the chemical reaction also every time. That's why we have to use some symbols which are already learnt in class 9, the chapter molecules and atoms and molecules. So every atom, the element has its own symbol. We should use the symbol for representing the element. Every time we cannot write the name, it is very difficulty. So we have used the symbol. Similarly, we can write every time the chemical reaction in terms of words. In terms of words. That's why we can. That's why we can use a chemical equation. So, for example, if it is write like this, carbon plus oxygen. Carbon plus oxygen gives rise to carbon dioxide. Carbon dioxide. So it is also represent the chemical reaction in terms of the words, in terms of the words. So it is also a difficulty to write everything. So that's why we have to use the symbols. Then we can write carbon symbol, carbon, carbon C plus O2 gives rise to carbon dioxide. C plus O2 gives rise to carbon dioxide. This represent a chemical reaction with symbols are the formulae. Such representation is called chemical equation. Such representation called chemical equation. So, a chemical equation is a shorthand method, a simple representation. A simple representation of a chemical reaction is called a, a chemical equation. A chemical equation. So here, as we discussed yesterday, in a chemical equation, the substances which are involved in a chemical reaction or chemical change, we can call them reactants. Then the new substance or the new product is called product. So to represent the direction or to represent the reaction taking place in particular direction, so we have to use a arrow mark from left side to right side representing. So the arrow sign pointing towards the right hand side is put between the reactant and the product. This arrow indicates the substances written on the left hand are coming to give the substance right hand in the equation. So this arrow we can pronounce it as gives rise to means reactants or gives products. To represent that we have to use an arrow mark. Similarly, for writing any other chemical reactions, yesterday as we discussed some, so zinc reacts with dilute hydrochloric acid. It gives us zinc chloride plus hydrogen. Zinc chloride plus hydrogen. Similarly, H2O plus O2 gives rise to water. Gives rise to water. Then other one whatever we have to take in. Uh, For example, nitrogen plus oxygen gives rise to nitrogen monoxide. Nitrogen monoxide. Nitrogen monoxide. Here N2 plus O2 are the reactants. NO, nitrogen monoxide, is a product. So we cannot write zinc react with dilute hydrochloric acid and give zinc chloride and hydrogen. Hydrogen and oxide combined together gives water. Nitrogen and oxygen combined together and give nitrogen monoxide. Nitrogen monoxide. So these all are the chemical reactions. These all are the chemical reactions. These chemical reactions are represented in short form. Represented in short form. So that representation of a chemical reaction or a chemical change by using the symbols or the formulas of the substances involved in the chemical reaction is known as chemical equation. Chemical equation. So we are able to write many chemical equations, any chemical equations for any kind of chemical reaction, or any kind of chemical reaction, right? So this chemical equation represent reactants, products, what are the substances are involved, the symbols and the formulas of the substances involved in a chemical reaction. Then we can make a chemical equation more informative. How can we make a chemical reaction more informative, making chemical reaction more informative? So we can make, right? So to make, next topic, to make chemical equation, chemical equation more informative, more informative. How can we make a chemical equation more informative? So, as we discussed, chemical reaction is represented with the chemical equation. This chemical equation gives some more information about chemical reaction. So, to make chemical equation more informative, so the equation which gives more information about the chemical reaction is known as more informative or information giving equation. The chemical equations can be more informative by different ways. The first one is representing or showing, showing or indicating. By indicating, by indicating physical state, by indicating physical state of the substances, by indicating the physical states of the substances. Then the second one is by indicating, by indicating heat changes, by indicating heat changes in the reaction, in the reaction, by heat changes. Then by indicating the conditions. The third one is by indicating, by indicating, by indicating the conditions, by indicating the conditions of the reaction. Condition in the sense it require any heat, pressure, or any catalyst, any catalyst, etc. Any special conditions, any special conditions are required. Any special conditions are required in the chemical reaction, and by indicating by indicating gas gas and precipitate, by indicating gas and precipitate of form formation, sorry, formation of precipitate. If any precipitate is formed in the chemical reaction or not, any gas is represent, any gas is represent in the chemical reaction or not. So let us discuss one by one. Indicating the physical state of substance, indicating the physical state of substance, that means solid, liquid, gas, or aqueous solution. Aqueous solution, the reactants and the products. If the reactants are the solids, we can represent with S, can represent with S. If the reactants or the products may form as a liquid, then we can represent with L. If the reactants or products are the gases, then we can represent with small g, then we can represent with small g. In case of aqueous solution, in case of aqueous solution, aqueous solution in the sense, aqueous solution means if any solid substance is dissolved in water, the resultant solution, the resultant solution is called aqueous solution. For example, salt. Salt is a solid. If salt is dissolved in water, it gives salt water. Salt water. Or this we can write as a salt solution. Salt solution. So any substance is dissolved in water, dissolved in water, that kind of resultant substance or the solution is called as aqueous solution. Anything is dissolved in water, we can write aqueous solution. It is represent with this represent with AQ. It is represent with AQ. AQ represent the resultant, so the products or the reactants are aqueous solutions, aqueous solutions. So if the substance is the reactants or the products, whatever it is, if they are solids, we can write symbol S. If they are liquids, we can write L. If they are gases, we can write gas. If they are aqueous solution, we can write aqueous solution. For example, here explaining with example. Right. So as we know, carbon is a solid. So we can represent with S. We can represent with S. We know oxygen. Oxygen is a gas. So we can represent with G. Can represent with G. The product is also also gas, carbon dioxide. So we can represent with gas. You can represent with gas, that means G. That means G. Similarly, here zinc. Zinc is a solid. Zinc is a solid. Dilute HCl. Dilute HCl, that means diluted. That means it is dissolved in water. Dissolves in water. So it is a aqueous solution. Then zinc chloride is also aqueous solution. Here hydrogen is a gas. Hydrogen is a gas. Similarly, hydrogen is gas, oxygen is gas, but water is the liquid. But the water is liquid. Right? In this way, we can represent with a small symbol. In case of solid, S. In case of liquid, L. In case of gas, G. In case of aqueous solution, AQ. Then coming to by indicating heat changes, is it exothermic reaction or endothermic reaction? Is it exothermic reaction or endothermic reaction? So, if in case of exothermic, in case of exothermic reaction, in case of exothermic reaction, we can write the symbol Q, or we can write plus heat. In case of endothermic reactions, in case of endothermic reaction, we can write minus Q or minus heat. Minus heat. Yesterday as we discussed change in temperature. In that change in temperature we discussed exothermic reactions and endothermic reactions. Exothermic reactions and endothermic reactions. Right? For example, as we know, when carbon is heated, when carbon is heated, so carbon is burns or reacts with oxygen, it gives carbon dioxide plus heat. Carbon dioxide plus heat. As yesterday we discussed, calcium oxide is dissolves in water, it gives us calcium hydroxide plus heat. Plus heat. So we can represent here carbon is solid, oxygen is gas, carbon dioxide is gas, and also we represented heat is produced, change in heat. Then calcium oxide is also solid, water is a liquid, it is calcium hydroxide also solid, right? This aqueous solution. This is a aqueous solution now. Then similarly, when nitrogen in this reaction. So nitrogen is a gas. It is also gas. Nitrogen monoxide is also gas. Plus here we can write minus heat because of this reaction is endothermic reaction. Endothermic reaction. So by absorbing the energy, by absorbing energy, heat, the absorbing energy, nitrogen monoxide is formed. So minus heat is representing heat changes. Representing heat changes. Then by indicating the conditions, by indicating the conditions under the suitable conditions, under suitable conditions, so we have to, for some chemical reaction, some particular conditions are required. For example, photosynthesis. For example, photosynthesis. Carbon dioxide reacts or combined with water vapor, it gives C6H12O6, C6H12O6, and also gives oxygen. Also gives us oxygen. For photosynthesis reaction, for photosynthesis reaction, we must know sunlight, that heat is required. Heat is available for green plants leaves in the form of sunlight, and we have to know chlorophyll. Chlorophyll also required. Chlorophyll also required. So chlorophyll and sunlight, chlorophyll and sunlight are the necessary conditions. Are the necessary conditions. These necessary conditions are written as either above the arrow mark or below the arrow mark. Above the arrow mark or below the arrow mark. So it compulsory. So under the presence of sunlight, under the chlorophyll, carbon dioxide reacts are combined with water vapor present in the atmosphere. Present in the atmosphere, it gives glucose, food, and liberate oxygen. Gives food and liberate oxygen. So here carbon dioxide is a solid, liquid, water vapor. Sorry, water vapor and gas. Generally, okay. Then here aqueous solution, and here the gas, and here the gas is produced. So in this way, for some condition, for some chemical reactions, for some chemical reaction, some suitable conditions are required. Some suitable conditions are required. Similarly, Similarly, calcium carbonate, calcium carbonate, CaCO3, it required. Or, for example, potassium chloride, KClO3, KClO3, potassium chloride. Potassium chlorate is dissociate, is divides into KCl plus oxygen. Potassium chlorate, potassium chlorate, potassium chloride, potassium chloride, and oxygen. For that we must heat, we must heat. So here the triangle symbol on the triangle symbol on the uh, arrow mark indicates that heat is required, and also required some another one, MnO2, MnO2, manganese dioxide, manganese dioxide. It acts as a catalyst. It acts as a catalyst. So catalyst, a catalyst is a substance which is not involved, which does not involve in the chemical reaction, but it changes the rate of reaction. So just like an inspiration, we have many persons inspiring. We are getting inspiration from many people. They won't impact directly on us, but from them we get inspiration. So we have to try. We have tried to get success in our daily life. Success in our life. So similarly, some of the substances are added into that reactants, into the reactants in a chemical reaction. That added substance does not involve in any chemical change, any chemical reaction, but it increases the rate of reaction. So if the reaction become more required faster, then we have to add some other substances. So delta represent in this reaction, delta represent heat, MnO2 is acts as a catalyst. So catalyst is a substance which does not involve in chemical reaction, does not involve in any chemical reaction, but changes the rate of reaction. So catalyst, catalyst, a substance which, a substance in which does not does not involve in chemical reaction, does not involve in chemical reaction, but change but change the rate of reaction, but change the rate of reaction. So such substance is called as a catalyst. The substance is called as a catalyst. Means some persons won't involve in any kind of matter, but they have to influences that situation. Influences the that situation. Such kind of persons are called as a catalyst. Similarly, for some chemical reactions, some of the substance should be added to change the rate of reaction. So here MnO2 is special condition. MnO2 is the special condition. So then one more by indicating gas and precipitate. So in a chemical reaction, if gas is produced, we can represent with upward arrow. We can represent with upward arrow. In case of precipitation, in case of precipitate is formed, we can represent with downward arrow. Can represent with downward arrow. So for example, let us take um, best example, carbon plus oxygen gives rise to carbon dioxide plus heat. Carbon dioxide plus heat. Here carbon is a solid, oxygen is a gas, carbon dioxide is a gas. So a gas is produced, so we can represent with arrow mark. We can represent with arrow mark, right? So a gas is evolved. So here also a gas is evolved, represent with the arrow mark. Here in this reaction also a gas is produced, can represent with the arrow mark, right? So here also a gas is formed, can represent with the arrow mark. Similarly, in case of any precipitation, in case of any precipitate is formed, then we can represent with a downward arrow. We can represent with a downward arrow. So yesterday we discussed uh, lead nitrate, PbNO3 taken twice plus potassium iodide. So here, then what will happen? Uh, lead iodide and potassium nitrate is formed. In this reaction, lead iodide is formed as a precipitate. Is formed as precipitate, and also yesterday we discussed barium chloride plus barium chloride plus sodium sulfate. Barium chloride plus sodium sulfate together gives barium sulfate plus sodium chloride. Here aqueous solution, sodium sulfate also aqueous solution. So here NaCl aqueous solution, then barium sulfate are formed as a precipitate. Barium sulfate formed as a precipitate. A white precipitate is formed. So solid. So solid. So barium chloride is aqueous solution. Means barium chloride is dissolves in water. It gives barium chloride solution. Similarly, sodium sulfate is dissolves in water. It gives aqueous solution of sodium sulfate. By combining these two, sodium chloride aqueous solution is formed, and barium sulfate is formed as a white precipitate. So in this way, we can make the chemical equation more informative. We know the chemical reaction is represented. The chemical reaction is represented with symbols of formulas. The simple representation of chemical reaction by using The symbols and formulas. Symbols and formulas is a chemical equation. That chemical equation gives more information by representing their physical state, or any heat changes, or any suitable conditions are required, any gas is produced or not, any precipitate is produced or not. So this is about writing a chemical equation. Thank you.